Good morning, students. So, in previous class, we are discussing about the solar energy collectors. Okay, what is photovoltaic cell? How you will convert the solar energy into electrical energy? So now in this class, we are discussing about the wind energy. Okay, in previous class, where we are see the introduction about the wind energy. Okay, so now in this class, we are discussing about the wind energy potential and its growth scenario in India. Okay, so what is the potential of wind energy in our India? Okay, see, India has the fourth largest installed capacity in wind power after China. Okay, after China, India placed the fourth place in worldwide in the production of the electricity from the wind energy. Wind energy has spread across the south, west, and north regions of India. So okay, so the wind energy will be spread in across south, west, and north regions also. So the potential of the wind energy is concentrated in the states of, okay, where in India, in which states we are producing the wind energy is nothing but Andhra Pradesh, Gujarat, Karnataka, Madhya Pradesh, Maharashtra, Rajasthan, Tamil Nadu, and Telangana. In these states, we are producing the small amount of electrical energy by using the wind energy. So, in all these states, Tamil Nadu has the highest installed capacity in the country with around 7.5 gigawatts. Okay, in our India, Tamil Nadu will produce the highest electrical power by using the wind energy. So that is 7.5 gigawatts of energy. Okay, Maharashtra has the second. Okay, so and the second place will goes to Maharashtra and it produce the 5 gigawatts of the electrical power. And will Gujarat will place the third place. And okay, so and it will produce the 4 gigawatts of the energy. Okay, this is the wind energy potential in the India. Okay, so see, you can see about the something about the wind energy. Electrical energy obtained from the harnessing the wind with windmills or wind turbines. Okay, by using the wind turbines. Okay, by using the wind turbines, here you can by using the wind turbines. Here you can convert the wind energy into the electrical energy. Okay, so the development of the wind power in India began in 1986. Okay, so in India you can start in 96 wind farms being coastal area of Maharashtra. Okay, first in 1986 you can started the electrical power generation from the wind energy in the Maharashtra, Gujarat, and Tamil Nadu. Okay, so at that time you can produce 55 kilowatts. Okay, by using the Vestas wind turbines. Okay, this is the company of the wind turbines manufacturing company. Okay, so wind energy is the one of the most promising alternative energy technologies of the future. So in future there will be very implements in the wind energy. At that time you can produce the a lot amount of electrical energy from the wind energy. Okay, during recent years the amount of energy produced by the wind driven turbines has increased rapidly. Okay, so nowadays in recent years the electrical energy developed from the wind energy will be increases. Why? Because there will be wind turbines development, wind turbines technologies will be increases. Okay, that's why the technologies in the wind turbines will be increases. So that's why, okay, the electrical energy produced from the wind energy is also increases. Okay, and so wind energy makes up the majority of 60 total renewable energy capacity installed in India. Okay, compared to all renewable energy sources, wind having the 68% of the installed capacity. Okay, so from if suppose for taking 100%, you can produce the electrical energy by using the renewable energy sources. In out of 100%, 68% energy you can produce by using the wind. Okay, so windmill. So here I will say that the wind energy will be produced by using the windmill or wind turbine. So first of all, what is in the windmill? Okay, a windmill is a structure converts the wind power or kinetic energy of the wind into rotational energy by means of blade. Okay, here is nothing but the wind turbine will convert the kinetic energy of the wind into the mechanical energy. So rotational energy is nothing but mechanical energy by means of blade. By using the blades, here you can convert the kinetic energy of the wind into the rotational energy or mechanical energy, that is nothing but the windmill. Okay, that term windmill refers to a wind power device that is the converting wind energy to mechanical power. Okay, here so it is primarily used to pumping of groundwater, extraction of oil from the seeds, milling of the grains. So in previous, first of all, so this first, so here the wind turbine will be convert the kinetic energy into the mechanical energy. Okay, that wind turbines. Okay, so primarily is used to pumping of groundwater, to pump the water under the grounds, extraction of oil from the seeds. Okay, all of you well know, so you can extract the oil from the seeds. Okay, if suppose sunflower oil, you can extract from the sunflower seeds like this. So to extract the oil from the seeds, so in previous days we are using the wind turbines. Okay, milling of the grains. Okay, to mill the grains. Okay, it has mechanical energy directly from the kinetic energy in the wind. Okay, so that means directly you can get the mechanical energy from the kinetic energy by using the windmill. This is achieved using vanes more commonly known as blade and sails. Okay, so I will say that here you to convert the kinetic energy into mechanical energy by using the blades. Okay, that blades is also called as vanes or sails. Okay, here, so by using the windmill, here you can produce the kinetic energy into mechanical energy. Whenever you can get the mechanical energy, at that time you can connect a one alternator to that turbine. At that time you can convert it into the electrical energy. Okay, so there are two types of windmills based on the axis of rotation, and they are, so here mainly you have two types of wind turbines or two types of windmills. These are vertical axis, horizontal axis. Okay, see, vertical axis windmills. In vertical axis windmill or horizontal windmill, the blades are rotated in horizontal plane. Okay, so around the vertical axis. Okay, here here the blades in vertical axis, the blades are rotated in horizontal plane around the vertical axis. Here axis is vertical, blades are arranged in horizontal. Okay, that is nothing but the vertical axis windmill. So these are very rarely used type of windmills in which that is collecting the wind is placed horizontally. So where you, so this is placed in which areas, means wherever the wind will flows horizontally, in that areas you can fix the vertical axis windmills. So next one is what? Horizontal axis windmill. Okay, in horizontal axis, the blades are rotated in vertical. Okay, in vertical direction the blades will be rotated and the axis will be placed horizontal. Okay, so those are nothing but the horizontal axis windmill. These are most popular type of which collecting the wind is placed vertically. So in most places the wind will flow. Here you have to use the most popular is horizontal axis windmills. So here vertical axis windmills are you are using the rarely. Okay, so there are four types of horizontal axis windmills. Okay, those are post mill, hollow post mill, tower mill, smoke mill. Okay, so again the horizontal axis windmills are, these are the four types. Post mill. Okay, so post mill means they consist from the large solid post on which top is mounted from collect the power, which the body mill being home for machinery for milling. Okay, they consist from the large solid post. Okay, on which top is mounted. So here you have the base is a very solid post. Okay, on that you have to place the blades. Okay, so that is nothing but the post mill type, hollow post mill, similar to the post mill but with a hollowed out the body. So this is also solid. So I will again see the structure, so at that time you can understood. Okay, so in so this is also similar to the post mill but this is having the hollow shape. Okay, so next tower mill. Tower mill is nothing but strong and tall windmill whose body is created. So this is like a fan. Okay, you have to see table fan. Okay, like this. This is a tower mill. Okay, you have the tower place, and that one you can place the rotor and rotor having the blades. Okay, you have mostly used this type of tower mill type. Okay, in horizontal axis also you have now the horizontal. Why? Because we can make a best advantage from the current wind conditions. So by using this one you can produce the current. Okay, by using only tower mill you can produce the current. Okay, so smoke mill, they were created to have the lower half the structure made from the stone or bricks, on top of the made light wood created along a wooden framework is called smoke. So this construction is somewhat placed under placed with bricks and some above placed with the wood. Okay, so that wood framework is called smoke. Okay, To better fight environmental conditions, the outside of the wooden frame was covered with some more durable materials, tar, paper, or sheetal, etc. So whenever these mills are placed, yeah, time due to environmental conditions, to protect that wood, you have to cover with either paper or sheet metal. Okay. Components of windmill. Here I will say is that windmill. So what are the main components of wind turbine or windmill? Following are the components of windmill. So first one is what? Blades. Okay, first main one is blades. These are the essential component of the windmill and they control the functioning of rotor speed. Okay, so these are the essential component of wind turbine or windmill. They will control the speed of the rotor. Okay, so rotor is also known as propeller. Okay, this is also called as propeller. This can produce mechanical power by its rotation. So whenever the rotor will be rotated, at that time only the mechanical power will be produced. Anemometer, this component is used for the measuring the wind speed. The instrument which is used for measuring the wind speed is nothing but the anemometer. So on the top you have placed the anemometer is also. So what is the purpose of anemometer is nothing but this component is used for measuring the wind speed. Okay, tower. This support the system being hold the blades and rotor together. So why you are using the tower means on the tower you can place the rotor and rotor surrounding you can place the blade. That means this tower will support the rotor and the blades together. Okay. Wind turbine a wind turbine converts the wind energy into electricity which can be used to power electrical equipment stored in batteries and transmitted over power lines. So what is wind turbine? A wind turbine converts the wind energy into electrical energy. Okay, so which can be used to power electrical equipment. Okay, that means for electrical purpose we are using. Okay, working when the wind blows past a wind turbine and its blades capture the wind's kinetic energy and rotated and turning into mechanical energy. So here I am says that turbine having the rotor and blades. Okay, so whenever the wind will flows, so at that time the turbine blades will be obtain the kinetic energy of the wind, so and then rotate. So whenever the rotation will be increases, that kinetic energy will be converted into mechanical energy. Okay, this shaft. So this rotation in internal shaft connect to a gearbox which increase the speed by factor 100. That brings the generator to produce through one shaft. Here you have to connect the generator, and that generator will produce the electrical energy. Okay, wind farm. A large number of wind turbines are built close together. Wind farm is nothing but wind turbine. Okay, so you have take the large number of wind turbines are built close together. So whenever you have to build all the close together, which is referred to as a wind project or wind farm. Okay, wind farm function as a single power plant and sends the electricity to grid. So whenever you have to produce the electrical energy, more electrical energy according to our capacity, at that time you have to combine all the wind turbines. Okay, that is called the wind farm. Okay, at that time that wind farm will generate the electricity and sends to the grid. Grid is nothing but at that time you have to grid. At a grid you have to store the large amount of electrical energy and it is given to the surrounding substations. Okay, so windmill versus wind turbine. So see, the important differences between the windmills and wind turbines are people have been using windmills for centuries to grind grain, pump water and do other work. So windmills is nothing but directly you have to use that mechanical energy from the windmills. So windmills generate mechanical energy but they do not generate electrical energy. Whenever you have to give a generator connection through a shaft, at that time this is nothing but the wind turbine. See, in contrast, modern wind turbines are highly evolved machines which more than 80,000 the harness converted into electrical energy. So they have to convert the electrical energy. Those are nothing but the wind turbines. Okay, so types of types of wind power generations. There are four main types of wind energy power generation. First one is utility scale wind. Wind turbines in the range of size from 100 kilowatts to several megawatts where electricity is delivered to power grid and distributed to end by user by electric. So wherever you have to use 100 kilowatts to several megawatts, that is nothing but our utility. For suppose for domestic utility, you are using the 100 kilowatts to several megawatts. So by using the wind turbines, you can produce this amount of electrical energy. Those are nothing but the utility scale wind power generation. Distributed or small wind. Small wind turbines 100 so below 100 kilowatts. Okay, that is directly the power a home or farm, small business. So that means if suppose in home, if suppose a small big house, so at that time you have to use the less than 100 kilowatts. So at that time in home separately you can arrange the wind power generation. That is nothing but the distributed or small wind. So utility wind means you can produce 100 kilowatts to several megawatts, and you have to deliver that power to the power grid. Okay, and you have to store the power grid, and you have to transmit for the utility purpose. Okay, but our home or separately some small business, so at that time, so but this is not connected to the grid, only for domestic purpose and business purpose you have to construct the small wind turbine, small windmills. So those are nothing but the distributed or small wind. Okay, next one is onshore wind. Onshore wind power refers to turbines that are located at the land and useful to wind generate the electricity on the land. So mostly the wind turbines are arranged, wind stations are arranged in hilly areas. Why? Because on hilly areas you have to airflow is good. Okay, so that's why here you have to, in most cases you have to arrange the this turbines on the coast, that means coastal, that means hilly areas. So whenever you have to place on land, so that is nothing but the onshore wind generation. Okay, to generate the electricity, these are generally located in areas where is a low conservation or habitated value. Okay, so very low utilization of electrical energy. So at that time you have to use the onshore wind. Offshore wind. Offshore wind power is the used wind farms constructed in the bodies of water. Offshore means nothing but seashore. So on the water, okay, usually in the ocean. Okay, so to harvest the wind energy, so whenever you have to place the windmills on the bodies of water and ocean, so that type is nothing but the offshore. So offshore wind turbines are the large than the land-based turbines, can generate more power. Compared to the onshore wind power generation, offshore wind power generation will be generate the large amount of electrical energy. Okay, see, this is the wind turbine, this is tower. Okay, so this is hub. Hub is inside this having the rotor, directly this having inside you can arrange the generator. These are the blades. Okay, so whenever so you have to see near in our Nellore district, I think in Nellore district Narsimhakonda, I think in that place we have the wind turbines. So in our Tirumala also, in Tirumala for Tirumala lot amount of electricity which is used is generated from the wind turbines. When you notice that you have also windmills in the Tirumala. Okay, so like this. So first you can see the types of wind turbines. Based on the rotational axis of the wind turbines with respect to the ground, wind turbines are classified as horizontal axis wind turbine and vertical axis wind turbine. Horizontal axis wind turbine. Okay, horizontal axis wind turbines means rotating axis of the wind turbine is horizontal. Okay, are parallel with ground. Okay, most modern wind turbines are horizontal axis wind turbines. And horizontal axis wind turbines are mainly composed of blades and hubs, nozzles and towers. A common wind turbine has 3 blades. The blades are mounted on the hub to form a wind rotor. The wind blower rotates in generator to engine the compartment generator. See, this is the horizontal axis wind turbine. Okay, so it says that this is the tower. Okay, so and this having the hub. Okay, on the hub you have to place the rotor. Inside you have placed the you have to place the generator, and this having the blades. Okay, so through these blades this will be rotated. Okay, so advantages. Horizontal axis wind turbine offers high output power. This having the high output power, the efficiency of horizontal axis wind turbine is high. Okay, and efficiency is also high, reliability is also high. The operational wind speed of horizontal axis wind turbine is also high. Operational wind speed is high, reliability is high, efficiency is high. Okay, and it gives the high power output. These are the advantages of horizontal axis wind turbine. Disadvantages: high initial cost and maintenance cost. Okay, initial cost, first purchasing the initial cost is high, to maintain the cost is also high. Noise problem and also very bad visible impact. Okay, need huge ground to install. So to install the horizontal axis wind turbine, you have to require the large amount of place. That means huge ground. Okay, dangerous for birds population. Okay, so whenever these blades will be rotated, whenever these birds will, for suppose sitting on the blades, so at that time it causes, so the electricity will shock the birds. Okay, so that's why dangerous for birds population, cannot be installed near human population. So these are population. Okay, so vertical axis wind turbine. Vertical axis wind turbine means rotational axis of the turbine is vertical and perpendicular to the ground. Okay, see like this. Okay, so this construction will be rarely used. Okay, this is the tower and here you have to generator. Okay, so through this is shaft, through shaft. Okay, so these are the blades. Okay, that means here you can place the vertical axis wind turbine means rotational axis of the turbine is vertical or perpendicular to the ground. Okay, the blades are attached to the top and bottom of the vertical rotor. So the most common wind turbine is Darius wind turbine. So here in this also so many types. Okay, according to the company. So mostly we are using the Darius wind turbine. They are 100 feet tall and 50 feet wide. Okay, height will be 100 feet, width will be 50 feet. So only few vertical are used nowadays because they do not perform well. Okay, this performance is not good. Okay, that's why mostly we are using the horizontal axis wind turbine. Okay, so are used for the low wind power generations. Okay, these vertical axis wind turbines are only used for the low power wind generation. Okay, advantages: cheaper, cost is cheap compared to horizontal axis, more easily installed. Okay, easily installed, transportable from one location to another. One location to another location to can transport the vertical axis wind turbine is also easy. Equipped with low speed blades. Okay, so speed will be low. Okay, low risk to the people and birds. Okay, so function in extreme weather with wind speed, even mountain conditions. So any places it will be extremely, any weather it can be works. So but less rotational efficiency. The efficiency will be less. But turbines have less rotational efficiency. Okay, lower available wind speed. Okay, wind speed also less efficiency. Okay, these are the advantages and disadvantages of vertical axis wind turbine. See, next one is wind power generation. Wind power generation means getting the electrical energy by converting the wind energy into rotating energy of the blades and converting that rotational energy into electrical energy by the generator. What is nothing but wind power generation? First you can convert the kinetic energy of the wind into the mechanical energy, and then that mechanical energy will be converted into the electrical energy by means of the generator. Components of wind power generating system. A typical wind power generating system and so you have to see components and how to produce the electrical energy. First one, blades. Lifts or rotates when wind is blown over blades. Okay, so it will, whenever wind will flows over the blades, at that time it will lift the air and cause to rotate, causing the rotor to spin. Okay, at that time the rotor will be spin. Most turbines have either 2 or 3 blades. Okay, so wind turbine having most 2 or 3 blades. Shaft, low, here you are using 2 shafts, low speed shaft, high speed shaft. Low speed shaft means the low speed shaft of the wind turbine connects the rotor hub to the gearbox. Gearbox means all total gears. Okay, so which are useful to connect the rotor and generator are placed in the gearbox. The speed of low speed shaft is about 30 to 60 rpm. Okay, speed is measured in rpms. rpm is nothing but revolution per minute. Okay, okay, the speed of the low speed shaft is about 30 to 6. The high speed shaft rotates with approximately 1500 drives the electrical generator. So this is only generate the gearbox. So whenever so for the gearbox you have to connect the generator. So that high speed shaft will be rotates the directly the electrical generator and rotates the, so this is nothing but a synchronous speed of the 1500. Any DC generator or motor will be rotated with this synchronous speed, that is nothing but the 1500 rpm, that is a constant value. Okay, Next one, rotor. Blades and hub together form the rotor which can produce the metal. Blades and hub. Hub means on the place which you are placed the blades, that is nothing but hub. Hub and blades together forms the rotor which can produce the mechanical power. Okay. See, this is the construction of wind power generation. This is the rotor inside. Okay. This is the top place you have called hub. These are the blades. Okay. So this is the tower. Total tower. Okay. So this is low. In this one you have called yeah system. Okay. So this is shaft. You have to see rod type. This is shaft. Through the shaft here you have to connect the gearbox. Through gearbox directly you have to connect the generator, and here you have to electrical controls. Okay. So first, whenever wind will flows through these blades will be rotated and spin the rotor hub. Okay, at that time the rotor will be rotated. Whenever this rotor will be rotated, at that time it will use the mechanical energy. Through gearbox, through this shaft, this mechanical energy is given to the generator. At this time, the generator will convert this mechanical energy into the electrical energy directly. Okay, controller. Okay, I will say that here you have using the electric controllers. Okay, so what is the purpose of controllers? Means for start of the mission at wind speeds of about 18 to 16 miles per hour, and shut off the missions about 55 control is required. Okay, to start the wind turbine, so you have to require 18 to 16 miles per hour. So at that time you have to require the wind per hour, you have to require 18 to 16 miles. So and to shut down 55. So for that control that air, here you are using the controllers. Brake. Why you are brake means to stop the rotor mechanically, electrically or hydraulically to emergency. In emergencies, brake is required. So whenever with the emergency conditions, any faults will be occurs at the time suddenly to stop the rotor. So at that time you have to require the brake. So next one is what? Gearbox. To connect the low speed shaft to the high speed shaft. Okay, so to connect the in between low speed shaft to high speed shaft, here you see here gearbox. This is okay. Here you have this rod. This total rod is shaft. So before gearbox, this is a low speed shaft. After gearbox, this is a high speed shaft, and this is a brake. Okay, so so that is the purpose of gearbox. Generator. Why you are using the generator? The electrical generator is usually so called induction generator or synchronous generator. So generators are so many types. Here you are using the induction generator or synchronous generator. It produces the AC power by taking the mechanical power as the input from the high speed shaft. Okay, so here input to the generator is nothing but mechanical. Whenever you have giving the input to the generator mechanical, at that time it can produce the output is electrical. Okay, so here the electrical generator is usually called induction generator or synchronous generator. It produces AC power by tanking the mechanical power. Okay, as input from the high speed shaft. Whenever you have to giving the input as mechanical, so at that time it will get the output is electrical. Anemometer. So anemometer is not connect. So anemometer will be not short means also separately the person will near that you have to measure by using the anemometer to speed how much speed the the rotor will be rotated. Nacelle is the housing that protects the main frame and components attached to it. So this total equipment will be placed in the one type of shielding, okay, to protect this total equipment. That is nothing but the nacelle. Okay, pitch, blade pitch or simply pitch refers to the turning the angle of attack the blades of a rotor into out the. So whenever pitch is nothing but whenever the wind flows over the blades, so at that time where the turning, okay, whenever the wind will touch the blade at first at what angle the blade will be turned, so that is nothing but the pitch. Okay. Next one is yaw drive. Okay, so yaw drive can orient upwind turbines to keep them facing the wind and direction changes. Downward turbines do not require a yaw drive. See, upwind, okay, upwind turbines will require the yaw drive. Why? Because to facing the wind direction towards the turbine blades. Okay, so but downwind turbines do not require the wind turbines. Okay, so at that time manually blows the rotor away from it. So at that time automatically the wind will flow through the rotor blades. A motor provides mechanical power to the air drive. Okay, to start the air drive, here we are using the A motor hub. The hub of the rotor is attached to the low speed shaft of the wind turbine. Okay, so hub, see here, this is hub. Okay, this hub is connected to the low speed shaft. Okay, so that means on the hub you can place the rotor blades. Cooling unit. The cooling unit contains an electrical fan which is used to cool the electrical generator. So inside you have to use the cooling unit. Why? Because whenever the generator will be rotated, some amount of heat will be produced in the generator. Okay, so at that time to cool that generator you are using the cooling water. Okay. See, electrical layout of typical wind farm by means of single line diagram. Okay, here you can see by means of single line diagram, here you can see the wind farm. So first, these are the wind turbine. This is a wind turbine. This is wind. Okay, this is gearbox I will say that. Okay, this is a generator. Okay, in generator you can convert the mechanical power into the electrical power. So first, here you can get AC. So from generator here you get the AC. That AC will be converted into DC either by using the converters. Converters means here you are using the, I think now you have SDC subject I think. So in that subject you can get the rectifiers, converters. Rectifier is nothing but it will convert the AC power to DC power. By using the converter, that is here you are using converters. In under converters the rectifier is also one type of converter. By using the converter, here you can convert the AC power into DC power. Next, that DC will be converted into the AC. Okay. And here a filter. Why? Because at that whenever you can get the AC to DC, so there will be not pure form of AC. So at that time there will be a compulsory some ripples. Ripples means unwanted portions will be present. Okay, so by using that one, here you can rectify that. At that time you can get, and that means some amount of DC will present in the AC by using that filters. Low pass LPF means here low pass filters. By using the low pass filter, here you can convert that is pure AC and you can transformer. Okay, here by using the transformer you can transmit to the consumers, electrical grid. Okay, so this is the layout of the wind farm. Okay. So in previous one, here you have to see the yaw control. Okay, and yaw. Okay, how to control the yaw. Okay, yaw control mechanism. See, yaw control would be an excellent way of controlling the power input to the wind turbine rotor. To control the power which is given to the rotor, that is controlled by using the yaw. Okay, so the part of the rotor which is closest to the source of direction wind, however, will be subject to the large force than the rest of the rotor. So what is the purpose of air control? Means it will be close the wind turbine to the wind. Okay, so at that time whenever the rotor will close to the wind turbine, at that time the rotor blades will be quickly rotated. Okay, so and this means the rotor will have a tendency to act against wind automatically whatever you are dealing with up. So that means that the air control will use that the rotor blades automatically rotated according to the wind, regardless of the either that is upwind or low wind. Okay, so that is direction is rather than, so the air control will makes that the rotation. Okay. Okay, this is the air control mechanism. So next you can see the pitch control mechanism. Pitch control adjusts the blades in the wind turbine by rotating them so that they are use the right fraction of the available wind energy to get the most power output. Okay, so pitch control. So pitch is nothing but whenever the wind will strike the wind blade, so at the time the blade will turn, so that angle will be called pitch. Whenever you can maintain the proper pitch control, so at that time you have to get the most power output. Okay, this maintains the turbine safety. Okay, so this by using this pitch control you have to maintain the turbine safety in the event of high winds, whenever high winds will be flows, at that time you can maintain the turbine safety and loss of electrical load and other events. Okay, the pitch control monitors and adjusts the angle of the wind turbines rotor blades. So here, so the pitch control will controls the angle of wind turbines. Okay, so which can measures up to 65 meters long, and all those control the rotational speed of the turbine. So up to, for rotor up to 65 meters wind also it will control the angle. Okay. Okay, although pitch controls play a vital role, they account for less than 3% of the wind turbines capital expenses. So whenever you have to reach the pitch control, so to maintain the pitch control, so it requires less than 3% of the cost. Okay. Wind power equation. So next one is what? Wind. The power generated in the wind power system can be expressed. The power which is required from the windmill is taken as the power equal to half into P into pi into R square Cp Cf into, okay, so half rho, okay, half into rho into pi into R square Cp into Cf V cube. This is V cube, velocity. Okay, so Ng and Nb. Okay, N suffix G, N suffix B. This is P, power. Here this is power generated in watts. V, here V cube. V means velocity of the wind in meters per second. Rho, here rho is nothing but density of the wind in kg per meter cube. Pi R square, the pi square shaft area. Okay, R is nothing but blade length. Okay, Cp, power coefficient. Okay, Cf, capacity factor. Okay, Ng, generator efficiency. Nb, gearbox efficiency. Okay, so the power from the wind turbine for a given wind speed is calculated by using the formula. So the power from the wind turbine for a given wind speed. Okay, this is the another formula of a wind turbine to measure the power, that is half Cp A V cube. C rho A V cube. Rho means air density, C means coefficient of performance, A means frontal area, that is, V means velocity of the wind. Okay, so the variation of the power from the wind turbine for a given wind speed can be so this is the wind speed you have to take in meter per second, and this is the power. So whenever the wind speed will be changes, here the power which is generated will be also, whenever the wind speed will be increases, the power which is produced is also increases. Okay, that is nothing but requires a parabola shape. Performance factors. Okay, the factors which describes the performance of the windmills are nothing but capacity factor. In previous formulas you can see capacity factor. Okay, so capacity factor is the ratio between power produced to the power that could be have been produced if the generation source operated at 100 efficiency. Okay, so that means actual amount of power produced. Okay, so actual, how much amount of power will be produced from that wind generation to power that would have been produced if turbine operated. So actual, if the turbine is always, the turbine will be not operated 100% efficiency. So actual, whenever the turbine will be rotated, so at that time actual amount of power will be produced to, whenever the turbine 100% maximum 100% output will be given, at that time how much amount of power will be produced. So that ratio will be called as capacity factor. So next one is coefficient of power, Cp. Okay, Cp is the ratio of actual electrical power produced by the wind turbine divided by the total wind power flowing into turbine blades at specific wind speed. So actual, whenever the turbine blades will be rotated, at that time the actual power will be produced to the, so specific wind speed. You have to mention specific wind speed. If suppose you have to mention 100 meters per second wind speed, so at that time the amount of power will be produced. Okay, that means specific, you can mention the wind speed. So that ratio will be called as coefficient of power. Okay, coefficient of power, coefficient Cp is a measure of wind turbine efficiency. To measure the wind turbine efficiency, here you have to use the coefficient of power. Okay, next one, tip speed ratio, alpha. The tip speed ratio is the ratio of speed of the wind to the speed of the tips of the turbine blades. Okay, speed of the wind. So at what speed the wind will flow through the turbines to the tips of the turbine blades. Okay, speed of the turbine blades. That is nothing but the tip speed ratio. Okay, next one is what? Pitch angle. Pitch angle is the angle between the longitudinal axis and horizontal surface, which depends on the wind velocity. So pitch angle means longitudinal axis. Axis you can longitudinally you can make a axis. Okay, that means horizontal axis and vertical axis. In between angle is nothing but pitch angle, which depends on the wind velocity. Okay, so this angle will be depends on wind velocity. Next, angular velocity of turbines, omega. The velocity at which wind turbines rotates or revolves is called angular velocity. First, at which velocity the wind turbine will be rotated, that velocity will be called as the angular velocity. Okay, so next you can see the performance characteristics of a wind power generation. The following are the performance characteristics of constant and variable speed wind power generation or wind turbine. Okay, power speed character. These are the power speed character. So previous I will see that diagram. Whenever you have to take an x-axis power speed, on y-axis you can consider the power. So at that time, those are nothing but the power speed characteristics. Why? Because these are called power speed characteristics, means these characteristics are drawn in between the power and speed. Okay, so from the power equation, Pm is directly proportional to omega cube. Okay, so that means the mechanical power that can be extracted from the wind depends on heavy wind speed. And so for wind there is so at that time, whenever the speed will be increases, so at that time power will be also increases. Okay, so that means directly proportional. So next one is the torque speed characteristics. This is the speed, this is the torque. Okay, so generator having the rotate means compulsory this having the torque. Okay, so torque is nothing but the force at a some distance. Okay, that means rotational energy is nothing but torque. Okay, so this is the turbine torque. Okay, constant turbine torque. Here you have to take as a reference line. This is the force to fault and this is the rated free fall. Okay, so before so whenever the turbine will be rotated, so at that time this is the actual torque speed characteristic. Whenever speed will be increases, torque will be also increases at a particular value, and it will again it will be that. So whenever the generator will be rotated, so it goes to high speed and automatically the speed will be decreases. So similarly, whenever the speed will be more, the torque will be also more. So again whenever the speed will be decreases, the torque will be also decreases. So that means constantly operate. So that is whenever there will be no fault, that means rated free fault. Okay, fault so any system, in some cases the fault will be occurs. If suppose in the system whenever the turbine blades will be rotated, if suppose the fault will be occurs, okay, before the fault, this is the characteristic. Whenever the fault will be occurs, at that time the torque will be, which produced is also decreases. Okay, this is the wave in between the free post. So whenever the fault will be occurs, at that time the torque value also will be decreases. Okay, so torque speed characteristic. So here Tm equal to Pm by omega. Okay, whenever the torque is directly proportional to the Pm and omega. Whenever velocity will be increases, torque will be decreases. Okay, so torque will be increases, power will be increases. So the torque and power are directly proportional and this is inversely proportional to the angular velocity. And this is the coefficient of power and tip speed ratio. Okay, so that means Cp. Here you can take the Cp and you can take the tip speed ratio. On x-axis you can take this tip speed ratio, gamma, and coefficient of power. Okay, coefficient Cp, at the time these are the curve. Okay, so at this point you can get the maximum efficiency. Okay, next one is coefficient of power versus pitch angle theta. Okay, coefficient of power, pitch angle. Okay, pitch angle will be increases, the coefficient of power will be decreases. Okay, so these are the performance characters. So next one is what? Angular. Whenever angular velocity of the blade increases, the turbine can. So this is a straight line, but here I will not show particularly. Okay, so so this is like a linear line. Okay, like this. Okay, here like this. So when angular velocity of the blade will be increases, okay, the angular velocity of the turbine is also increases. Okay, so that means those two are directly proportional. So next one is site selection consideration for wind turbine generating system. So to place the wind power station, so at that time which type of site will be suitable. So see, high annual average wind speed. Okay, wind speed will be high. Okay, availability of anometry data. Okay, so anemometer is nothing but the to measure the wind speed. Okay, so that place will be available to take the anometry data. Availability of wind curve at the proposed site. Okay, so next, wind structure at the proposed site, altitude of the proposed site, okay, local ecology, surrounding area, okay, distance to road or railways. You can see the distance to the road and railways, nearness to site to local center or users, okay, that means near to the load centers, okay, terrain and its aerodynamic, okay, favorable land cost land will be also favorable, nature of the ground. Okay, to install that tower, the nature of the, you can see the ground nature also. Okay, so up to now in this class we are discussing about the how to produce the wind electricity from the wind, and okay, what is nothing but windmill and what is the wind turbine. Okay, and what are the types of wind turbines, vertical axis wind turbines and horizontal axis wind turbines, and what are the factors. Okay, those are all, and which site is suitable for the wind power generating system. Okay, that means the having the high wind speed will be high, so the place is suitable to take the anometry data. Availability of the wind curve. Okay, so to take the wind curve, so that place will be available. Wind structure, so how the structure of the wind at that side, altitude of the proposed site, altitude angle, local ecology. Okay, so there will be distance is a proper distance to road, to see the road and railways for the wind power station. Okay, so in this class we are completed the wind power generation.